Hello again, and we reached chapter 4 of this learning experience, and I can already see how much I learned looking back at chapter 1. If I could, I would ignore chapter 1, 2, and half of 3. It was only at the last stream we went from just looking at the language reference and moved to this site called the sig.guide, and we just learned step by step instead of going over the language itself. Where did we get to the last time? I don't even remember. Maybe I should do some notation saying where we got to. Maybe I can see it in the code. Yeah, it was some error handling. I'm pretty sure it was just around this. We talked about defer, which only runs at the end of the block, or scope, as I would say, and the error defer, which is only run at the end of the block if an error occurred using try. So for instance, in this one, we will create an error when this is called, or we will return an error because it tries to run this one, but this one will always return an error. I think it was up here. We created a function, yeah, failing function that just returns an error. So when it returns an error, this one, even though it's defined before the call to this one, it won't be called unless this one fails. So if this one didn't fail, this would never be run. So I think we got that. Error unions, I think that was where we stopped. Maybe that was actually the last thing that we just copied over. Yeah, because it didn't really make sense, so we just stopped there. But let's see, error unions returned from a function. Error unions returned from a function can have their error sets inferred by not having an explicit error set. This inferred error set contains all possible errors that the function may return. Okay, so if a function, that's just the exclamation point and nothing else. In some of the previous ones we told it, yeah, it can return this error, but apparently we can just set this and we can access it by doing this. Yeah, I get this, but I'm not sure I get this, because then I would have to know exactly which errors could be returned. It says that the stream is unstable, sorry. Okay. I hope it's good enough. But let's test it. Let's test it as we've done before. So we have this create. We can hopefully, as always, run the test. Why am I not able to run the test? Oh no, what have I done? That's kind of weird. Let's just try run everything. Let's see if I made some. Didn't look like it. Yeah, there it is. It runs. So why can't we run tests anymore? Oh no. Yeah, it wasn't supposed to be. It wasn't supposed to be like this. But apparently it's just the way it is. Maybe I should clean up a bit so I know what I'm working on. But still, it's kind of annoying that I can't just run the test now. Have I forgotten something from a few days ago? Something specific that I need to do to run the tests? Didn't I just right-click them and run the test? Run tested cursor. Okay, that works. So it just doesn't have the error for me, so I can just click it. Again, I don't know Visual Studio Code as right now, so that's something I'll have to look into. So for now, I will just run test at cursor, Control Shift C. Control Shift C. Nope. That's a shortcut for the operating system. So Control Shift C I can't use, but I can click it. That's okay. So that says it can return this error. But what if it could return a different error? Can we go to definition of this? Why can't I go to that? This must be defined somewhere, right? No definition for error found. Is error a keyword? But previously we made this one. There are no exceptions. Errors are values. Yeah, but can we just add errors by error dot something and make extreme typos? I think that's a bit weird. But again, if that's the way we're gonna do it, then that's the way we're gonna do it. Apparently it is. Access denied. Undo, undo. But what if we could access it with a value and just say unsigned 16. Now I have to remember something. Oh God. Index And then if index equals 1 to this, else return access granted. You don't like the else? If this return this, else return this. Don't we have else in SIG? That would be a surprise if we don't. Or am I forced to use this? Maybe I am. So if say 1 here, and again right click run. Huh. Error access granted, not a member of destination error set. Exactly, it's not part of the set that we handle. But how can we handle then extra possible errors? Can it be something like this? Save. Yes. Okay. It wasn't clearly defined. Okay, it was just below. Once again, I have shown that I have to read more than just the first couple of lines. This has been an issue for me since what do we call it? Primary school. That I read a sentence and I start working on a problem defined in that. And then a lot of times I found myself solving something that was actually stated in the next sentence. So maybe if I just read all of this, I would already have known this. But then again, I concluded it myself, and that's also a learning experience, and I guess I will never forget it now because I figured it out myself. We can also OR it together. So let's try that. Just to see if we can do this. Error dot or error dot this. Doesn't like that. Do this. Save, and let's try it once again. No. Expected type found. No. So that didn't work. Can we do it something like this instead? It should be kind of the same, so I don't get why that would have worked. Nope. Expected type found. It expected a type, but it found error access denied. Yes, that is the exact same one. It's not because it needs to be a slice or something. Because we are actually setting const x to this type and equaling it to this one. We can try to make it into this slice type I'm not used to and see if that makes a difference. It doesn't. So using this notation, I'm not sure how to. But we still have the option to do it. Like this. Yeah. Does it have to be defined in full in one line so you can't add them together? Because what I did before was I only took the first two parts and then tried to add them together with this one. So right now I should be able to do this. Oh God. Errors. Let's see if that works. It did. So maybe this part is what's now giving issues because it knows it's errors. Can we do this? Or was that what we tried before? Might have been. No, that also works. Okay. So we can do this. What we cannot do was this one, right? Where we did it like this. No, that apparently can't be done. But I feel like that's exactly what they're saying that we should do. Oh, that is. So we need to define them not by error dot, but error. So it might be able to do it if we do it like this. Again, we need to learn the notations. Apparently this notation is a bit different than expected. Yes, okay. So this one groups these together as they are errors. It's a bit, yeah, it's a bit weird way to do it. I would have expected you could just take the direct errors. What is it using that one? Like this one? And just all those together, but apparently you can't. You can all them together if they are this array of, or it's not an array. I'm not sure what to call it yet. Set, a global error set. Okay. Any error is the global error set, which due to being the superset of all error sets, can have an error from any set coerced to it. Its usage should be generally avoided. Okay, so we shouldn't use any error. But if you're not completely sure what something returns, then I guess that's the one you would use, right? Okay, on to switch. Switch, the first time I met switch, I guess, was in C#. Switch case. But in Kotlin, you don't have the case part. You have kind of the same notation as you have here. It looks familiar. Works both as a statement and as an expression. Okay. The only thing about these switch statements, of course, I'll just read through it and make sure that there's not something different from the other languages I know. It can take ranges. It contains specific values, and you have this else to handle everything else that wasn't defined. So it looks good. I saw a video yesterday about changes in the newest version of Kotlin, and apparently they changed something about the else statement, so you could do both undefined, like the else where it's not something that is here, but if you switch on an enum and you have certain values and you have them all defined and an else, if you then add something to the switch statement, you could still have an underscore that catch those values. I know that sounds a bit weird, and it is, because why doesn't the else just take it? But apparently it's possible to have values that is not in the enum, maybe. Yeah. This one is for SIG version 0.13. Oh, they actually do have .14, but apparently it looks to be in development. So we won't go over that one yet. I know I'm a bit behind then, because I'm pretty sure that we have SIG version 0.14. Can't we just see the version? No. Ver, no. Oh, 15. Oh my god. So probably things have changed. So what we are learning right now, there might be some small changes. Yeah, it's still not a language that has been fully developed and has version 1. So we will have to accept that what we learn might change a bit. But I guess that the overall idea would still be the same. That was switch, nice and easy. If you have something in that range, it will run this code. If you have one of these values. And the only thing in question here is if this range covered to, let's say, 11, would this one trigger or would this one trigger when the value is 10? Because it's included in multiple. I'm not sure if the compiler will catch that, but in Kotlin, I believe that it will always do the checks one by one, so it would if this matches, it would run that code and that's it, and exit out. It won't run both. Should we do a test? Let's do a test. Just to make absolutely sure. We're gonna add it to the top. That might be the best way to do it, so I have an idea how far we gone, how far we come in this. That worked. Then let's say this one is 11, and we put it in here, and we say, no, let's just keep it at 10. Then it is included in this one, and it's included in this one. But how do we define if it's one or the other? We output a message. Range. And apparently this print does take args no matter if they're empty. Don't like it, but oh, to do that, yeah, it's just a value and no arguments. Save, run it again. Run. Oh, it actually catches it. Duplicate switch values. So it does see that this is included in this one. I like that. It's not a big thing, but just having it tell you up front that you have included it into this. Then this, oh, we have a notation here I'm not used to. 3 dots. Maybe that's both included. So it includes both -1 and 10. And this might not work. Okay, so 3 dots. I think this one is still gonna be an error. Yeah, because it's still included in both. So we're gonna take this one, move it down to 10, run it again, and everything works. So as expected. Oh, not as expected. It actually makes the check at compile time, so that's very nice. I'm not sure that Kotlin does that. It just runs the first one that matches. But I'll have to test that. Runtime safety. Okay. Seg provides a level of safety. Where problems might be found during execution, safety can be left on or turned off. Seg has many cases of so-called detectable illegal behavior. Detectable illegal behavior, okay? Meaning that illegal behavior will be caught, causing a panic. Or just a runtime error? Why panic? Okay. With safety on, but will result in undefined behavior with safety off. Users are strongly recommended to develop and test their software with safety on despite its speed penalties. For instance, runtime safety protects you from out-of-bounds indices. Yes. We like this. We have 3. We try to access at index 5. This should, of course, give us an error. And then the error shows up again. The run test. Why is it not on the other tests? Why is it right there now? That's weird. Okay, fails. What does it say? Yeah, index out of bounds. Panic. That's okay. I like that. But I know that it adds a check to every array. Every time you index into an array, it has to have in the array when you create it, it needs to have some kind of information about the length of it. So when you try to access it, it can say this is out of bounds. And yes, it's a good safety check to have, and all newer high-level languages have this. But I know the speed penalty. It's like, I guess in Unity you have some, I also do some game development in Unity from time to time when time allows. And there's a lot of null checks, and you can actually circumvent some of them. And this is kind of the same here. You just check that it's inside the range of the array. So nothing new there. You may disable runtime safety for the current block. Okay, you can do it by block. That's nice. Safety is off by some build modes to be discussed later. So you can do it on block level, but you can apparently also set it globally in the build settings. So I guess you can, in this one, there would be options to optimize the optimize mode. Debug, release safe, release fast. I guess that fast isn't safe. But I am already at optimize mode. No further explanation of release fast. Release small, I have no clue if that's how it's gonna compact the code more than in fast mode, but yeah. So okay, we can add this one line and just say, will it just return whatever is in that memory part of the memory? I know that it says that it would be undefined behavior because we don't know what's in that location in memory, but that's okay. Can we run it again? Yes. But then now I'm curious what value it finds at that location. Of undefined off, but at undefined location. B. Pointless discard of local. Yes, I know, but again, it finds it like that. Let's run it again. Oh, that didn't work. Why not? Oh, I'm not using it. Undefined location is 97, and if I run it again, I might not get the same value, right? But I am. Okay. Then what if we say .4? Oh, then maybe we could just do this. It should do it by itself, right? 86, 86, 86. And if I say 5, now it's a 0. And then, of course, if I say .6, it should be inside the bounds, and we should get our correct value. Cool. Unreachable is an assertion to the compiler that a statement will not be reached. It can tell the compiler that a branch is impossible, which the optimizer can then take advantage of. Reaching an unreachable is detectable illegal behavior, as it is of the type no return. It is compatible with all other types. Here it coerces to U32. Test unreachable. Set this to 1. If x is 2, then 5, else unreachable. That makes sense. That makes a lot of sense. Reached, unreachable code. Yeah, because x is 1, so it's not 2, so it's unreachable, and it will complain. Here is an unreachable being used in a switch, else is unreachable. That I like. So the code breaks. We kind of use something like this in Kotlin. But we just throw an exception and tell where in the code it went wrong. So I would really like to be able to get some more information than just we reached something unreachable. I don't know how logging works in SIG, and yeah, it's probably possible to log this specific information. But again, I'm thinking if you're running in some kind of optimized production environment, you won't get the line information and so on. So I would really love to be able to add some information to this one. And now to the fun part. Pointers. It's so powerful, but also opens up a really big can of worms. Normal pointers in SIG cannot have null or null, 0 or null as a value. Okay. Do we have a null pointer then? They follow the syntax star t or multiplication t. I don't know what we normally call this, where t is the child type. Referencing is done with ampersand variable, and differencing is done with variable dot star. Okay, let's take it nice and slow, because this is something I need to have down. I need to know this. Pointers. Make a variable. Increment the content of x. The content, the variable. But then why use it? I guess that it will be clear why to use this when working more intensively with pointers. Because you can just use t, right? No, oh, because it just needs, this is not just adding it, it's actually a function. Again, read the entire code before. Okay, I jumped down here to get the entry point of the test, and then they use this function. I should just have read that function first. So it takes a pointer to a U8, and it takes the pointer, then reference, and then accesses the pointer. See, that's just a weird, but that's the way it works. So here it's more about syntax than understanding the flow of the code or the function of the code. It's the syntax. The dot. I would have expected this to be kind of like this, because here we have a function pointer, and to access the num where it is, I would just use num or ampersand num. So let's run it. Where do I have this? There it was. Let's run this. Passed. But this can't be just... No. Found compile time integer. It expects a U8. That's what it's getting. Line 12. But because I access it, it's being treated differently. Reference by... Then what about doing this? That's not even possible. Invalid left-handed side of assignment. Oh, we're working... it doesn't have a return type. It's void, so we need to manipulate the specific address of this. I don't understand why the bitrate, average stream bitrate too high, unstable. It's kind of weird because it's more or less a solid screen that doesn't change that much, so it shouldn't cost anything. Weirdness. Okay, so we have an explanation to why this is. We want to point it to a U8. This could be whatever, as long as these two match. SIG also has const pointers, which cannot be used to modify the reference data. Referencing a const variable will yield a const pointer. Const, exactly the same as up here, just as a const instead of var. And setting one to the other. And you can't do this because this is a const and you set it to point to the same address. So you can't update this one. It wouldn't bother me if, like in C, this was possible with some workaround. So we get the address of this one without it seeing it being a const, and we could just change it. I find it a very short introduction to pointers. But yeah, I think I skipped this one. Trying to set pointer to a type to the value 0 is detectable illegal behavior. Then we have this. What is this? Pointer from the int. Panic. Cast causes pointer to be null. Why? Why can't it cast to this one? You make a variable, that's 5. Oh, 5, and then you subtract 5, and then you try to set it to whatever that. Why would you ever need this? If you got it returned from some external library, maybe? Yeah. That makes sense. Okay. So you could just have written pointer from int 0 and see that it wouldn't work. And this just shows that the compiler is smart and can figure out that this one will return in, or not compile time. It's a panic, so it's a runtime. Fair enough. Pointer size. Okay, so we get a bit more about pointers. I guess not much. Usize and isize are given as unsigned and signed integers, which are the same size as pointers. Size of usize and isize are given as unsigned and signed integers, which are the same size as pointers. Besides this, this is actually something I would like to just test. Size of usize. Yeah, something like that. And I actually just want to print out the size of this one. Size of usize. It's 8 bits or bytes. Size of this function returns the number of bytes it takes to store T in memory. Size may contain padding bytes. Huh. So usize, is that 64? Because U8, to my knowledge, isn't. That should just be 8 bits, right? Yeah, usize is 1. So U8 and usize has nothing to do with each other. Oh, size of a pointer to a U8. Okay, so we have 64 bits of addressable memory or pointer ability. We can point to anything within, what is 64 bits? Is that the 2 point something gigabytes? Or is that the 16? Two to the power of 64. No, that's the gazillion one. So it's 32 bits. That is the, yeah, and then signed, so divided by 2, we have around this one, 2 point something billion. Perfect. So the size of the usize equals the size of a pointer 2. I guess that u8 doesn't matter here because it just says something about the pointers and not the whatever it's pointing to, right? That should still work. Yes. I guess almost. Oh, this will always be 62. The pointer, yeah. So no matter what we put in here, right? The pointer to something should always be the usize. Can we point to something weird like whatever type something? We do this. Yeah, it would still work because no matter what, a pointer to something addressable will always have this size. Okay, so usize and isize, unsigned and signed, but they will always be the same and so limited by the number of bits and this having 1 bit less because it needs a signed bit. Makes sense, but a good point to make. But I guess this is defined by the system itself, if it's a 64-bit system or a 16 or 32. Let's see, many item pointers. Most programs need to keep track of buffers which don't have compile time known length. Many item pointers are used for this. These act similar to their single item counterpart using the syntax array pointer to type, or how should you call it, many item pointer of type instead of one single pointer. This one I'm still not comfortable with, but again, seeing it in different scenarios and code, it will make it a lot more clear. Indexable, no, there's no index. Here, yes, of course, you can index into the array of pointers. Support arithmetics, no. Pointer +1. Okay, that seems weird if it's not the index itself. Any size, including unknown, must be known. Yes. Coerce from an array pointer, no. From an array pointer. So you can't cast an array pointer to a single pointer. Okay, there's a lot of stuff to unfold. Maybe that should be for the next time. I'm not sure I'll get through this in the next 6 minutes. So we hit the 1 hour mark as I still need to work. So I have to stop the stream. But I would have liked to finish off pointers, but it is what it is. We can take it next time. I'm not sure when that will be, but as always, I will upload this to YouTube as well, and you can comment and hopefully help. But if not, had a good laugh of what I don't get about this, or just enjoyed looking at me fumbling around trying to learn Sick. So until next time, I guess that was it. Have fun. Bye.